Hello folks, we are coming to the part 3 video of the exercise 1.4. We have already finished the question number 1, 2, 3, 4, 5. Now we are coming to the question number 6. The concept is the same. We have learned about union and intersection. It's just the same that's getting continued in the next two questions also. Only thing, the number of sets will vary. Sometimes it's two set at a time, sometimes 4 set, sometimes 3 set and so on. So that's how we are supposed to be doing this. Our question number 6 tells that they give us a set A, B, C, D as it is given here. And then they ask us to find all this. Whatever is given over here, these are subparts which we need to find. A intersection B, B intersection D, such things. This we are supposed to find. So we can get it started right away by looking at the set. Checking out whatever intersection or union or whatever that is necessary as per requirement. Let's see how we can do it. Amongst A and B, A intersection B, amongst A and B, let's check if there is anything common. Between A and B, there is this elements 7, 9 and 11 common. So we can have the listing like this, 7, 9 and 11. Then they ask us B intersection C. That means between B and C, what is common? The elements 11 and 13 is common between B and C. Then we have A intersection C intersection D. That means amongst these three set, whatever is common, we need to list it. I don't think anything is common because between A and C, though this 11 is common, between C and D, that 11 is not common. So therefore, I think we will have between A, C and D. Nothing common. Then we have A and C. Amongst A and C, there is 11 alone that is common. So you can have 11 common. Then between B and D, amongst B and D, we have again nothing common. So that is also empty. Then A intersection B union C. Now whenever we have both these operations coming up together, let's find out what is B union C and then we will find out what is its intersection with A. B union C for us, it's going to be the collection 7, 9, 11, 13. B union C, and then we can have 11, 13 is already there. So you have the 15. So this is your collection B union C. We are having it in intersection with A. So when we look at the intersection with A, this element 7, 9 and 11 is common. So therefore, you have the final listing coming up to 7, 9 and 11. So what we did is we first found out what is B union C. And then we looked at the intersection because of the brackets. Because the bracket was put there. So we did that first and then we went to the next. Then we have this A intersection D. Amongst A and D, there is nothing common. So it is going to be the empty set. Again, the same kind of thing here. B union D. Let's see what is B union D. It is a collection 7, 9, 11, 13, 15 and 17. And then we have A intersection. So let us check what all things can be common. You can have 7, you can have 9, you can have 11, which is common amongst them. So that is how you get the listing. Then we have A intersection B, A intersection B again in intersection with B union C. So let us find out these two collections first. A intersection B we already have. It is 7, 9 and 11. B union C, whether we have, actually we have it here. So we have A intersection B and we have B union C. Both of them are there here. We have to see what is its intersection and that comes to 7, 9 and 11. So that is our intersection. Now we look at A union D. Whether we have it? No. So A union D is 3, 5, 7, 9, 11, 15 and 17. That is A union D. And B union C, of course we have it? No. So B union C, it's a collection 7, 9, 11, 13 and 15. So amongst both these, you have to get the intersection. So when we look at common elements, you can have 7, 9, 11, 7, 9, 11. You can have 15 also. So you have 7, 9, 11 and 15 as the required intersection. So this is about the question number 6. Now in the question number 7, they are telling us, they give us A, it's in set builder form. I have converted into listed form so that it's easy for us to get the answer. The question number 7 says that A is a set of all x such that x is a natural number. Then B is set of all x such that x is an even natural number. Then C is a set of all x such that x is an odd natural number, and D is a set of all x such that x is a prime number. That is exactly what we have done there, but we have written it in the roster form. Now the question says that having given all this, you are supposed to find all this which is written over here, the 6 subparts. So let us see how to go about doing it. We have A intersection B, that amongst A and B, what could be common? Obviously we can see that these 2, 4, these are common elements from between A and B. So it's basically going to be B which is common. If you carefully see, it is B which is common. Then between A and C, this 1, 3, 5, 7, they are common. So basically it is C which is common. So here you have C common. Then between A and D, if you look at A and D, again it is D which is common, because all these elements are always contained there. So it is D which is common. Between B and C, nothing is common. There is absolutely nothing that is common, so it's an empty set. Between B and D, certain elements are common. Not certain, only one element is common, and that is 2. And between C and D, we will have pretty many common elements. We can have 3, we can have 5, we can have 7, we can have 11. Next number could be 13, and that could be the common element. So this is about the question number 6 and question number 7. Later questions we are taking up in our next part. Thank you.